Hello. Now this lesson is for the lesson that I'm away, which is on decimals and just looking at the different types of decimals that we have. Now, I'm just going to outline. Here we have two types. We've got terminating decimals and we've got recurring decimals. Now, at the moment, I'd expect you guys to already know something about each of these. Now, obviously, terminating decimals are special because they stop. Okay? The word terminating means to stop. And so it's basically a decimal number, a decimal that ends. It may have repeating patterns, but it comes to an end. So 2.37 doesn't go on forever. 4.91 does not go on forever. 0.0037 does not go on forever. Okay? So really what makes a terminating decimal is that it stops. Whereas a recurring decimal is a decimal that has a pattern of numbers that repeat over and over and over again. And they go on forever. Okay, that's what makes recurring numbers so special. So for example, or should I say, also, you'll know it's a recurring number because it may be represented with a little dot on the top. That dot represents the repeating pattern. So if it's got 0.4 with a dot on the top, that's the same as saying 0.444444 forever and ever and ever. But sometimes you might have a situation where you've got two dots. Now, why are these two dots special? They're special because all of the numbers from the beginning, the first dot to the last dot, are the repeating pattern. So in this case here, you've got 0.3732, 3732, 3732, 3732 forever and ever and ever. It is 0.3732 recurring. Okay. Now another type of decimal that we might come across is an irrational number. And we've looked at those. Oops, I'll just get it aligned. Any second now. We know irrational numbers because they go on forever. They are infinite, okay? But they show no repeating pattern. And they cannot be expressed as a fraction or a decimal as an exact value. In other words, if you represent them as a fraction or a decimal, you have to approximate. So we represent them instead as a surd. So what are some examples of irrational numbers? Pi is an irrational number, 0.31415926653. And if you can go on until you turn 80 years old, non-stop saying pi, you can keep on going and it will never repeat. That's just what it is. Square root 3, which is a surd, 1.732050808, blah, 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 and it will go on forever and ever. So let's have a look at these. Terminating or recurring. Now for these we're going to need our calculator because the way that we find out if it's terminating or recurring ultimately is by doing whatever this fraction is telling us. This is the same as saying 5 divided by 6. And so you can type this into your calculator. 5 divided by 6 equals 0.83333333333. What do we see here? We see 3's going on forever and ever. That's a repeating pattern. So that's 0.83 with a dot on the top of the 3. So it is obviously a recurring number. What about 11 divided by 40? Same thing. 11 divided by 40, or 11 over 40. 0.275, therefore obviously it's terminating. Oops. There's a quick way with these Casio calculators. A nicer way of doing it. These Casio calculators can flip between fractions and decimals on their own. And so if I put fraction button, 11 over 40, press equals, all I have to do is just press SD and it flips between. So I see straight up that 11 over 40 is 0.275. Bit of a note though, once you do it, it's a fraction, 5 over 6. You have to press equals. And now that it's down there, you press SD and you can do the same thing. Hope it helps.